Hello, my name is Jordi Vilchez Lozano, and I'm going to present my course report. The structure of the presentation is as follows. First, I will start by explaining the main objective of this work, that is the initial problem to which we want to give a solution using machine learning and deep learning techniques. Then I will present the dataset used and a small analysis of its content. I will continue with the proposed solution since the models designed are based on a proposed structure. Then the models developed are going to be explained, and they are already all based on the same neural network structure as I just said, but with a small variation. Finally, I will analyze the results, give some conclusions, and as well some ideas about future steps. The aim of this work is to propose a solution to a voice-based gender recognition, as this has several uses in many areas. For example, it could be the base for a speaker recognition system. I chose this topic because after analyzing the presentation of my classmates, I realized that this topic had not been chosen yet and was part of the example proposed in the subject. So I decided to make this report based on this topic. Well, as we already know, the human voice is a unique communication tool, since each sound wave of the human voice carries a different frequency. In addition to different characteristics of the human voice, in this work we focus on gender. So I'm going to present the dataset they used, and we're going to analyze its content. The dataset was extracted from the IEEE Dataport webpage in the subsection of dataset. This database was created to identify voice as male or female, based upon acoustic properties of the voice and speech. The datasets consist of 3,168 recorded voice samples collected from male and female speakers. The voice samples were pre-processed by acoustic analysis in R using some different functions. In this case, for example, the warble R spectrum function was used to extract some different features. Here we can find some of them. There are 20 features, for example, the mean frequency, the standard deviation of the frequency, the median frequency, the first quartile, the third quantile, interquantile, and other features. This dataset can also be found in Kaggle, and now I'm going to visualize these features and this data to have a better idea of the content. Here we can see, for example, distribution, the range and density of the mean frequencies. As well, we made a plot of the relation of the different features, as you can see in the image, and this was to have a better idea of the data we have in our dataset. The content was divided into in the X data, in the features, and the data that is the label male or female, depending on the speaker. So once this data division is made, I'm going to follow with the proposed solutions. Here is the neural network proposed. As you can see here, there are 20 inputs that are the different features of the data set that we obtained from the IEEE webpage. And as you can see here we use bias, and the first hidden layer is a free neuron layer. The second hidden layer has 2 neurons, and finally we have an output layer with a single neuron to identify if there is a male or female. First of all, the data the label was male or female. That was changed to a binary classification, 1 for male and 0 for female. And this way was better and easier to make and to program our models. As you can see, this is a binary classification problem. It can be solved using classifier, and it's not even necessary to implement neural networks on the same solution. In any case, as in other subject, the use of machine learning and classifier has been studied. In this case, I have chosen to develop the neural network using the Keras library, and as well I tried to implement this neural network by hand, implementing the necessary functions. For example, forward propagation, backward propagation, cost function, etc. So I'm going first to explain the model developed with Keras library. As you can see here, it's very simple with this powerful library to design or to create our neural networks. In this case, the model used was sequential, and then we can see that here the different neurons were added, and as well the input with 20 features. Here the activation function for each layer was hyperbolic tangent, and excepting for the last layer that is activated with sigmoid function. The split of data in this case was 35% of the data for testing and 55% for the training. This second variation is the same model of the previous one, but including a K-fold cross-validation using a Keras classifier to maximize our ability to evaluate the neural network's performance. This is possible in Keras because we can wrap any neural network such that it can use the evaluation features available in scikit-learn, including K-fold cross-validation. To accomplish this, we follow some steps, really simple steps to add this validation. In this case, is 5-fold cross-validation. Here we can see the code using the Keras classifier instead and executing some functions. Then we continue with the third variation. To design the neural network, different aspects must be taken into account before starting, including the function necessary to carry it out. First, we initialize the variables for a fully connected network. These variables will correspond to the weight, vectors, and bias of each layer. So then it's necessary to specify the function for forward propagation. That is the outputs of each hidden layer. As you can see here, we follow these equations, and as well we calculate the cost function. In this case, as you can see here, we did it with this code. Then, in the same way, we calculate the back propagation, as is shown here. We calculate the function that make the predictions of the neural networks, and as well another function to data the parameters. It means the weight of each layer. So after that, we put all this together in a function to generate the network. And as I said in the report, this implementation was not necessary. We have a lot of libraries, powerful libraries to do these kind of things. In fact, this way is more tedious and very prone to make some mistakes. But I consider it interesting and even more after knowing the rich material, information, and examples that we can find different platforms, for example, from Kaggle, GitHub, and other kind of platforms. So I decided to follow some examples and to do it this way. This gives me a better idea of how it works without just using a function. Then I'm going to present the result, on some conclusions. Here we have the three variations of the structure proposed and the results. For the first neural network, we have chain and test accuracy rounding the 97% approximately, with 150 epochs, and that is split of 35% for test and 65% for training. The second model, second variation, was using K-fold cross-validation. Here we have the result for each fold. The accuracy is between 89% and 95% with 150 epochs. And finally, for the last model proposed, we have an accuracy for training and for testing of 97%. In this case, with 5,000 iterating, a learning rate of 0.001. So these are the results. In this case, we are making an accuracy classification because it could work well if there is an equal number of samples belonging to each class. In this case, 50% for males and 50% for females. That overfitting is a challenge in machine learning and deep level problems. The second model proposed K4 cross-validation was implemented to try to avoid this problem, and I think that is the reason that it has the worst results, because it performs a better validation of the model. So after some execution, the parameters more accurate for each model were set as shown in the column of parameter columns. Sometimes were made with different parameters, but the results were affected clearly by an overfitting issue or underfitting for the first executions I tried. So this is the result. I'm going to present right now from future steps. I think it would be interesting to adjust this model better in order to obtain better results. Likewise, to make a more in-depth comparison of the efficiency results of our models, it would be ideal to be able to find a larger data set, or at least an audio file bank, to later obtain the voice characteristics and build or augment the data set. The problem, as I said, it could be solved using different types of neural network, LSTM, RNN. It could be interesting to compare the result with some simple classifiers to see really which one is the better to resolve this problem. As I said, I think this is not a very complex problem. It's a binary classification, it's a classifier. It could be interesting to compare this using as well other structure of the neural network, because in this work, the neural network was the structure of the neural network was proposed, and then the models were made based on this structure. So it could be interesting as well to find or to do another structure to see how it works. So that's all for the moment. So if you have any question, please feel free to ask. And that's it. Thank you for your attention.